Good morning to all. Welcome in Mr. Khan Academy. Today I am going to cover the fifth video on second series, that is 2.5 Servo Amplifier and DC motor service drive. Before starting this video, you can check 2.3 heat dissipation in DC motor and velocity profile optimization, as well as 2.4 inertia matching, that is just recently uploaded on my channel previously. If you are my new viewer, अगर अभी तक आपने मेरा चैनल सब्सक्राइब नहीं किया है, then please hit on this icon, okay, subscribe icon, subscribe my channel to motivate me to make such video in future. अगर आपको पसंद आ रहे होंगे, and if you are having any doubt, any suggestion, any feedback, please mention in comment box, and please hit the like button. And the last and important thing, please share this video with your friends, those who need it. आप अपने दोस्त को बताइए अगर उनको भी इस सब्जेक्ट में इंटरेस्टेड है. And if you want to watch the videos in second series, previous videos, then please hit the card icon. यहाँ पे आइकॉन अवेलेबल है, यहाँ पे क्लिक करके आप बाकी वीडियोस के भी लिंक चेक कर सकते हैं. Now let's see how much topic I covered in second series and how much topics are left. 2.1 principle of DC operation is already completed. Modeling of DC motor behavior also completed and I covered. Heat dissipation in DC motor and velocity profile optimization is also covered. 2.3. 2.4 inertia matching, just previously I covered. Initially I thought that before starting this series I'm going to cover all these three bits in a single video, but as now when I understanding that inertia matching is very important and very lengthy topic, because of that I make a separate video, and I'm making a separate video on servo amplifier DC motor service, right, which is going to cover in this video. And in future I'm going to cover the stepper motor in detailed, okay, characteristic, classification, principal operation, step angle, the modeling, driver methods, stepper motor performance, as well as the working of AC induction motor and voice collector. अगर आपको इन सभी के बारे में नोटिफिकेशन चाहिए, अपडेट्स चाहिए, then please hit the subscribe button, by which you will get the notification whenever I'm going to upload these videos. And you can check the videos, the previous video 2.1, 2.2, 2.3, 2.4, this card icon, यहाँ पे क्लिक करके आप चेक कर सकते हैं. Okay, let's start with the servo amplifier. The first bit, what exactly is servo amplifier? Servo amplifier is a power op-amp operational amplifier capable of supplying the required current and voltage to the motor. What exactly is the meaning? That suppose the motor I want to control, like their direction, the torque, okay, in that case I need to vary the current and voltage, and my supply voltage is constant, and might be it is not as per the requirement or specification of my motor. In that case, what if I will do? I required some intermediate, some device that will be control the current and voltage irrespective of supply voltage according to motor requirement. In that case, I am going to use the servo amplifier. The amplifier typically receives an analog command signal within plus minus voltage and amplifies it to the required level of current and voltage. Whatever the voltage is there, irrespective of that voltage, whatever the requirement is there, desired output is there, is suitable for the motor. According to that, servo amplifier change the current and voltage and supply that current and voltage to the motor. That is the working principle of servo amplifier. Now there are two types of servo amplifier: linear amplifier and PWM, pulse width modulation switching amplifier. The principal output stage of either amplifier can be one of the two basic design. Principal output stage of either amplifier can be one of the two basic design of these two amplifier: T-section servo amplifier and S-section servo amplifier. And before learning in detail what exactly is the linear amplifier and PWM, pulse width modulation switching amplifier, first we'll check what is the T-type servo amplifier and S-type servo amplifier. This T-section and S-section. Then first we are studying the T-section servo amplifier. The T-section servo amplifier required bipolar power supply, okay, positive as well as negative bipolar, and two complementary transistors, that is a Q1 and Q2, as shown in figure. There is clearly mentioned that Q1 is NPN and Q2 is PNP. Suppose if you want to learn in detail exactly what is NPN, PNP, what exactly different type of transistors are there, अगर आप चाहते हैं ये भी मैं cover करूँ, then please mention in the comment box as per requirement. अगर आपको लगता है मैं ये भी topic cover करूँ, then in future as per your request will cover these topics also. Now here what we are going to cover, we are try to control the direction of motor. Then for that what I will do, I will supply the positive voltage to channel 1. Channel 1 is connected to base of this transistor Q1 and Q2, okay, through resistor R1 and R2. Okay. Now as I'm supplying the positive voltage, then NPN will be forward wise, PNP will be reverse wise, because that characteristic of that transistor. Then as I'm supplying the positive voltage to Q1 as well as Q2, then as Q1 is a forward wise, Q2 is reverse wise, Q1 will be on and Q2 will be off. As Q1 is on, current is flowing across the voltage is flowing, positive voltage is flowing across the Q1, then across the motor to the ground. Because of the direction is from positive voltage to ground, okay, I'm getting clockwise direction. We are getting the clockwise direction through the motor. Now suppose I change the control voltage, instead of positive, now supplying the negative voltage. What will happen? Again the negative voltage I'm supplying Q1 as well as Q2, but as the Q1 is NPN transistor and Q2 is PNP transistor, now Q1 will be reverse wise, Q2 will be forward wise. That means Q1 is off, Q2 is on. As Q2 is on, the current is flowing from minus voltage across the voltage is flowing across this Q2 transistor to the motor to the ground. As I'm supplying the negative voltage, I'm getting counterclockwise direction. Like this, I'm controlling the speed as well as the direction of motor. The speed I'm can control with the help of base current, that we'll see we'll study in future. Okay, that type of transistor. Now meanwhile the working principle of T section is like this. As the ground is not floating with respect to power supply, the current and voltage feedback we can easily implement in the case of T section servo amplifier. That is the advantage of T section servo amplifier. Now let's start next S section servo amplifier. S type servo amplifier. The H stage consists of 4 transistors, Q1, Q2, Q3 and Q4, and single unipolar power supply. Why single unipolar power supply? As you saw in the previous slide, we required positive voltage V plus V and minus V across this circuit, but here only I required plus V, which is flowing across this transistor. Only I required positive V. Because of that I am mentioning the single unipolar power supply is required. It wire in a such a way that only 2 transistors are on at a time. तो इसका सर्किट डायग्राम ऐसा किया गया है, खाली 2 ट्रांजिस्टर एट टाइम ऑन रहेंगे, बाकी 2 ऑफ रहेंगे. Now let's check the working principle. Here 2 channels are there, channel 1 and channel 2. Channel 1 is connected with the Q1 and Q4, okay, and channel 2 is connected with the Q3 and Q2. Now I'm supplying the positive voltage to channel 1. This is a control voltage. I'm not here I'm talking about the power supply, so this is a control voltage. Control voltage might be positive, negative, but power supply is always positive. Because of that I'm mentioning the single unipolar power supply. The control voltage is positive. As I'm supplying the positive voltage to Q1 and Q4, then Q1 and Q4 will be on, Q2 and Q3 will be off. Okay, now the current is flowing across the Q1 from the motor from left to right, then Q4, then ground. As this is off, current is flowing, but as the circuit is open, current is not passing across this transistor. Current is only passing across this Q1. Okay, now we can say I'm getting the clockwise direction. We will get the clockwise direction across this motor. Now suppose instead of positive, now I'm supplying the negative voltage to channel 2. As I'm supplying the negative voltage to channel 2, now Q3 and Q2 will be on, Q1 and Q4 will be off. As Q3 and Q2 is on, the current is flowing across this transistor, and as this Q1 and Q4 is off, it is open, the current cannot pass across this transistor. Because of that, the positive voltage is flowing across Q2 instead of Q1. Now it's flowing to Q2 from right to left to the motor, then Q3 and then ground. As it is flowing from right to left, I'm getting counterclockwise direction. Like this I can control the S section servo amplifier. As the ground is floating, we cannot take the feedback of current and voltage to this circuit. S section servo amplifier. Now let's start. What is a linear amplifier and PWM, pulse width modulation? Linear amplifier. In a linear amplifier, the power transistors are operated in their active range. Whatever the supply is there, in that supply constantly the transistor is working in linear amplifier. The linear amplifier supply constant output voltage, as I said, which is often a fraction of total power supply. Might be power supply is different. Suppose I'm supplying the 50 voltage, okay, 50 watts of power, suppose I'm supplying, but at the end motor required only 20 volts. Then continuously through the linear amplifier I'm supplying the 20 watts only instead of 50 watts irrespective of input. Therefore the collector emitter voltage drop. Then 50, as I said, input is 50 watts of power, exit are required only 20 watts of power. The difference between 50 and 20, 30 watts of power, the collector and emitter voltage drop. The voltage drop I am getting, the conducting transistor is high. Because of that I am gaining power dissipation in collector is significant. Because of losses are increasing in linear amplifier. Power losses, because of the power losses, the efficiency of linear amplifier is low. Their use is restricted to low power amplifier. As the drawback, as voltage drop increases, heat dissipation increases. Because of that, only we are using the low power amplifier, not for the high power. As I'm using low power, definitely heat dissipation will be low. That is the advantage as well as disadvantage of linear amplifier. The circuit design is simple, implementation is simple, linear amplifier, but losses are PWM switching amplifier, pulse width modulation. The switching amplifier generates a voltage that switch between high and low level of DC power supply. Means in the previous case, it's supplying, means in linear, it's continuously supplying a single voltage, a single type of voltage continuously, a fraction of total input. But here what I'm doing in pulse width modulation, the switching amplifier generates a voltage that switch between high and low level. Two types of level power supply I'm using. One is a high supply, one is a low supply, and between these two range I'm switching continuously in PWM. The most common method of amplifier switching is PWM, pulse width modulation. Means it's switching technique. When I'm switching from high and low, that time I'm using the pulse width modulation. Here the transistors are switched at a constant frequency and the resulting output voltage varies between the two extreme values. As I said, high and low value. Between two values, the output voltage varies. Because power transistor are either off or in saturation, the power dissipation in collector is considerably less than a equivalent linear amplifier. As in linear case, as I explained, the voltage, suppose output are required 20 watts, input is 50 watts, the difference between output and input is 30 watts. 30 watts continuously voltage drop is there. But as I'm switching between high and low, the average whatever I'm getting the required value, no doubt, but losses are very less for the same equivalent linear amplifier. Because of that, pulse width modulation is almost exclusively when power requirement exists 100 watts. More than 100 watts power is required, okay, in that case we will prefer the PWM switching amplifier. Less than 100 watts we will prefer the linear amplifier. Now let's see in detail the difference between linear and versus PWM switching amplifier. Might be you are not understand properly whatever I explain in that theory. Let's see in the block diagram. Suppose linear servo amplifier is there, in which I am supplying the power 40 watts and 5 ampere as a current. Then total power is 200 watts. 40 into 5, 100 watts power I am supplying to the linear servo amplifier. But my desired output to motor, I required only 10 watts of voltage and 5 ampere as the current. And what is how much power is required? 50 watts. But input is 200 watts. That means total 150 watts power I am dissipating in terms of heat. The power dissipation 30 watts and 5 ampere. Okay, in collector to emitter, the voltage drop as I explained previously. The net efficiency, I am supplying 200, only using 50%, 50 watts. Net efficiency is 25%. Okay, the losses 75% are losses in linear servo amplifier. Because of that, we are not using the linear servo amplifier for the higher power. Only we are using the low power. Now, what exactly we are doing in a PWM servo amplifier? What exactly is there? If suppose linear amplifier working in this manner, then what exactly in which manner working a PWM servo amplifier? Again, this we are keeping the power supply is constant. Supply voltage is 40 watts and 5 ampere. Again 200 watts power supply I am supplying here also. And desired output is again 10 watts ampere and 10 volts as a voltage and 5 ampere as a current. Okay, but here what I am doing, I am varying as I explained the two extreme values. The two extreme values now here 0 watts and 40 volts. The 40 watts only 25% of times I am using, and 0 watts I am keeping 75% of time. Whatever the time is there, the time period, within that time period 25% of that time period I am switching on the 40 watts and 75 times I am keeping the circuit is off. The average of these two, ultimately I am getting 25% of 40 volts is 10 volts and 5 ampere as a current. Means I am getting the desired output also with minimum losses. Because of that, net efficiency of PWM is 98%. Here 25%. The frequency in which they are ranging is, we can achieve 15 megahertz. After 15 kilohertz, after 15 kilohertz, the losses are increasing in PWM also. But ultimately more than 100 watts we can use PWM servo. That is the difference between linear versus PWM servo amplifier. Now last bit, in second part of this video, DC motor service drive. What exactly is there in a DC motor service drive? A typical closed loop control system is as shown in figure. It's called a servo system. Okay, typically closed loop control of a servo system, in which again we are using the controlling the DC motor to run the load. The components include in that the motion controller, the power amplifier, that is servo amplifier, the motor sensors, the motor and tachometer position and torque sensor. These are the different sensors are there. The controller receives command from the programming controller. Here some programming is already done, and the instruction is sent from the controller to the servo amplifier, the terminal or switches, but the most commonly we are sending the signal from the computer. The controller generates the proper signal and initiate the motion command to the drive. The controller initiate the generate signal, whatever the signals are there, on, off, to increase the speed, to decrease the speed. That signals I am sending from the motion controller servo amplifier, and according to that servo amplifier supply the current and voltage to the DC motor. Now power amplifier delivers the necessary current to the driver motor. As I said, whatever the signals are there, according to that I am changing the current and voltage, and according to that I am getting the required torque as well as RPM from the DC motor. The motor generates the torque proportional to the applied current to the move to load. Okay, as I said, whatever the commands are there from the motion controller, servo amplifier change the current and voltage, and according to that much proportional I am getting the torque. Okay, and we can run the load. Then ultimately the sensor determine the velocity. Here sensors I am using, and position of the motor. The tachometer check the velocity, and position sensor check the position, and report the result back to the close to the control system. Here I'm checking the signals, okay, after in between DC motor and load, and that I'm sending to the motion control to check whether we achieve the desired value or not. If suppose we are not achieving the desired value, then again motion controller sending the signal to increase or decrease the current according to requirement. A tachometer is typically used to measure the velocity, angular velocity, and either a shaft encoder or resolver is used to measure the angular speed, position sense, and torque sensor is optional, okay, to measure the torque. And ultimately the motor, the closed loop is generated, and this is the working principle of the working of DC motor service. Now suppose whatever that I explained, might be you get a partially, you might be having certain doubt somewhere, then in that case you can refer to Applied Mechatronics. You can use a Smiley F. Mud, Oxford University Press book. I refer this book to explain you regarding all these concepts. These books are available, okay, online, various shop. These books are available, you can purchase it and you can read this book. You will get that in detail knowledge what exactly whatever I explained the previous two bits. Okay, now here that much in this video. In future definitely I will activate the test. It is not activated right now. Okay, to check it, please check in the description box. If the test link is available, then definitely you go through the test and you prepare for the test and check how much knowledge you gain. Suppose if you are getting the more marks, 80%, then you are getting the maximum knowledge whatever I explained. But if you are supposing the less marks, then my suggestion, again rewatch this video and again appear for the test and give the test honestly. Again, the introductory part of this second series, the 2.0 electric actuator system, the video is available on my channel. Please go through that video and check how much topics I covered and how much topics are left and exactly what I'm going to cover in that particular bit. In brief, I explain all those things. And you can check 2.1 principal operation of DC motor, my first video in second series. Please check this video also. Again, my sincere request to everyone, if you are not subscribed till now, please subscribe my channel by clicking over here to motivate me to make a such video in future. If you have any doubt, any comment, any feedback, positive, negative, please mention in the comment box. And hit the like button and please share this video with your friends also, those who need it. Okay, meanwhile, here we complete this video, this lecture. again we will come back with the next video very soon. Okay, now I conclude this video. Thank you very much. See you soon.